Hello, everyone. Welcome back from the break. I'm not going to waste too much time. We'll get straight to these presentations. We'll start off with Rishab, Mahajan, and Cindy Skrukrud with their presentation, Development of Water Quality Model to Support Fox River Implementation Plan.
Great. Thanks, Ben. I'm Cindy Skrukrud. I'm chair of the Fox River Study Group, and I want to thank you for joining Rishab and me for this presentation. I'm going to cover a brief history of the Fox River Study Group before turning it over to Rishab to update you on the latest modeling tools we are using to evaluate options for improving conditions in the Fox River. Here's what we're outline of what we'll be covering today. The Fox River Study Group is governed by a 9-member board that includes representatives from government, water reclamation districts, and environmental and watershed groups as listed on this slide. The group was organized when representatives from major wastewater facilities and environmental groups told the Illinois EPA that we wanted to work together to resolve water quality issues identified in the Fox River. And now, 20 years later, Illinois EPA continues to let us take charge as an alternative to a TMDL, which is a typical cleanup plan usually developed by an agency like IEPA itself. The study group's area is the southern half of the Fox watershed from one of the largest dams on the Fox River near the city of McHenry called the Stratton Dam to the mouth of the river near Ottawa. So you can see on that map that how our area is the lower half of the whole watershed. The water quality issues which the group is focusing on are related to the over-fertilization of the Fox River. This slide shows the reaches of the Fox that the Illinois EPA has listed as impaired due to high phosphorus, where dissolved oxygen levels fall below state standards, and locations of nuisance algae. The many dams on the Fox main stem in this part of the watershed also play a role in creating still pools where algae can thrive. We accomplish our work through in-kind efforts and with the help of consultants like Rishab and Geosyntec, and with entities like the USGS and the Illinois State Water Survey. A major okay, I think we missed a slide. Go back a slide. Oh. Okay, anyway, go to the next slide. In 2015, the Fox River Study Group released the Fox River Implementation Plan that made use of models developed for us by the Illinois State Water Survey. The FRIP, as it's called in short, calls for wastewater treatment plants to remove phosphorus for their discharges if not doing so already. Upgrades are underway, and by 2022, a 75% reduction in phosphorus loads to the river will be achieved. An update to the FRIP is due to Illinois EPA by the end of 2022. That is what the group is making use of our models for to now prepare. Next slide. As part of improving our understanding of the river, we have hired the USGS to monitor at our studies area upstream boundary at the Stratton Dam in McHenry. And then we are also currently working with the Forest Preserve District of Kane County to study the impacts of the removal of the dam they own in Carpentersville. The Fox River Study Group is coordinating, in some cases funding, pre and post removal studies on fish, macroinvertebrates, mussels, and water quality. The Illinois State Water Survey analyzes and organizes the data we are collecting. Their 2019 trends report shows promising declines in nutrients and algae in the river over the last decade. This full report can be found at the Fox River Study Group's website. With Rishab's help, the group is using our models to help us determine the best next steps to continue to improve the quality of the Fox River. And I'm turning it over to Rishab now.
Thank you, Cindy. So as Cindy mentioned, we have been working with the Fox River Study Group to develop these models to figure out what could be done to address issues in the Fox River. So I always like to start with this quote: all models are wrong, but some are useful. So our intent here was to work with this study group and create useful models that can help to figure out what could be done to address issues in the Fox River. So the modeling tools that the study group has invested in are composed of a link modeling framework. They consist of a watershed model, which gives you the flows and the tributaries concentrations as well as the flows. And it also consists of an Instream model, which models the hydraulics, which is your flows and velocities, and the water quality model that simulates the in-stream dynamics, what's happening to the dissolved oxygen, what's happening to the algae. And I'll talk about briefly more about these models. So the watershed model is actually the HSPF model, and this effort was originally developed by the State Water Survey, and they had basically developed 33 sub-watershed models, which you can see on this picture on the left, which these models provided a continuous simulation of the flows and the concentrations that were coming from these tributaries that were in the lower Fox. This HSPF model also included the wastewater treatment plants that are on the Fox River. So with these models, we are able to estimate what is the load that's coming from the point sources as well as the non-point sources in the tributaries itself. We then provide that input to the Instream model, and the Instream model starts from Stratton Dam all the way to the mouth of the Illinois River. It's about 98 miles of the river that this model is simulating. This includes the impact of the dams and wastewater treatment plants on the Fox River main stem. So dams do play an important role in how the dynamics of the river are. This call to K model, call to KW model, it is a dynamic model, so you can basically look in time, over time, how the water quality is changing, and it has been calibrated to in-stream data. Now, I can probably give a whole presentation on the calibration, but because we are short on time, I'll link you to the calibration and the model development report below here. What I want to really talk about is how we've applied the models to simulate what different management scenarios could be taken to improve the water quality in the Fox. So before I go into the scenarios, one very interesting thing that happens in the Fox, and maybe also in other rivers as well, is the Fox has algae in the form of cystonic algae, which is sort of the algae that's suspended in water. But it also has benthic algae, which is on the river bottom, right? And they have an interesting sort of back and forth where benthic algae really grows in slow moving and shallow reaches of the Fox. But if you have a lot of cystonic algae in the water column, it sort of reduces the growth of cystonic algae by shading. So if you only basically just take care of the cystonic algae, the benthic algae has more light available now, and so it starts growing if you only look at just addressing the cystonic algae. So that's something we found when we've been running our models, and I'll show that in the next coming slides. What we did for looking at these models is we've said, okay, what is our baseline scenario? So for our baseline scenario, we chose this period of the growing season of 2012. If you guys remember, this was probably a very low flow period in the Fox. This was a period of documented drought and algae growth. So this really represents the critical flow conditions in the river when there was a lot of algae in the river. And what we did was we looked at, okay, what are the targets for achieving water quality? So this table shows the dissolved oxygen targets. And then the FOX study group has also developed a chlorophyll target of 149 micrograms per liter. That's based on the Illinois EPA assessments of whether a reach is impaired or not, and looking at the associated chlorophyll data. So once we had the baseline model, we used the model to compare that to the impact of the different management actions. And the management actions that we looked at are reducing the upstream TP boundary, which is most of the load that's coming from Wisconsin, reducing the load that's coming from the tributaries, reducing the load that's coming from the treatment plants, and then finally, how does dam removal impact the water quality? And I'll just give you a preview of what we found and then walk you through the results. So what we found from our results is the upstream boundary and the tributary load reductions have minimal impact. Really, the impact that you see on the water quality comes from the treatment plant load reduction and also dam removal. So I'll walk you through those results now briefly. So for the upstream boundary scenario, what we did is for the baseline model, we had a time varying TP boundary condition. And so basically what we did is for looking at the impact of the upstream total phosphorus, we reduced the boundary by 50% and then also by 70%. But then for the second scenario, we capped it at 550 micrograms per liter, which is the Illinois EPA criteria for lakes, basically. So so what you see on this figure, the black line is the baseline TP that's coming from upstream. The red line is a 50% reduction. And the green line is basically showing the 75% reduction capped at the 50 micrograms per liter. So we put that in the model, and then we looked at different variables. We looked at dissolved oxygen, we looked at total phosphorus, we looked at cystonic algae, and we wanted to compare the results of the baseline scenario to this scenario. And this is the results that we got. So there is a lot of information on this graphic, and you'll see similar graphics in the next coming slide. So I'll just take a moment to explain this graphic. So we start from the top left. So this is basically showing the growing season minimum dissolved oxygen. So every reach, we take what is the minimum dissolved oxygen during the whole growing season and we plot it. So the black line represents the baseline, the red line represents the 50% upstream TP reduction, the green line is the 75%. And then similarly, we're looking 5th percentile, we're looking at total phosphorus, the lines remain the same. We're looking at if you go to the top right, we're looking at the median chlorophyll. We're also looking at the median benthic algae. And then we're also looking at time when the cystonic chlorophyll is greater than that target of 149 micrograms per liter. And now when we look at the results, you do see that because TP is reduced, the upstream TP gets reduced, the overall TP downstream is also reduced. That makes sense. But and also with the TP, you get a reduction in cystonic chlorophyll because some of that upstream TP is also associated with the chlorophyll in the total phosphorus. Benthic algae, like I said, because the cystonic algae decreases, it actually increases because there's more light available to them, and so they can grow faster. With the DO, so what happens is in the upstream reaches, there is an improvement with the upstream TP reduction, but if you look at the downstream reaches, you see that the DO actually starts to drop because of increased benthic algae. So it has an opposite undesired effect, but this is just looking at if there's only that scenario, which is the upstream TP reduction. So then when we go to the tributary TP load reductions, and for that scenario as well, we looked at reducing the load that's coming from the tributaries by 50% and 75%. So I'll show those results as well. With these results, it's very hard to see the distinction between the three lines, and that's because it didn't have much of an impact. Really, the downstream Fox River watershed is really dominated by the loads that are coming from the wastewater treatment plants. So the tributaries have some impact. There is a slight decrease in chlorophyll concentrations. The locations of the tributaries are actually shown by these stars. And so you can see that it doesn't have much of an impact in terms of the water quality. Yes, there is a slight decrease in chlorophyll. DO doesn't really change. So it doesn't really have an impact on the main stem. That's not to say that reducing the load from the tributary is not going to help. It's going to help with the water quality in the tributaries, but really the main stem is dominated by the wastewater treatment plant loads. So then we started looking at the treatment plant loads, right? And what we did is in the baseline model, we had a TP concentration based on the actual data. And for the different scenarios, we started reducing the TP effluent concentrations to 1 milligrams to 0.5 and then 0.1 milligrams per liter. So in the next few slides, I'll show those results. So this plot is just showing what happens if you just go to the TP 1 milligrams per liter baseline and the TP 1 milligrams per liter. The red line is the line that tracks the 1 milligram per TP effluent. So what we see here is, of course, there is a substantial reduction in in-stream TP. That's really where the major wastewater treatment plants come in. You see an overall reduction in systolic chlorophyll. The amount of chlorophyll, the time when the chlorophyll is above the target is also getting reduced. The benthic algae, initially it decreases because it's controlled by nutrients in the middle reaches. But then as you get down, you also have a decrease in systonic algae. So benthic algae can usually survive at very low nutrient concentrations as well. So as you go downstream, because there's more light available, the benthic algae actually starts to grow more. So what that results in is really down in the initial middle reaches, you see an improvement in the DO with reducing the TPU to 1 milligrams per liter. But after that, you actually see the opposite trend. If you only look at reducing the effluent TP. Then if you look at the TP 1 milligram and 0.5 milligrams per liter, you see very similar pattern, but there is, again, very slight improvement in the upstream reaches, but not much of a difference, again, going from 1 milligrams per liter to TPU 0.5 milligrams per liter. And then finally, if you go from 0.5 milligrams per liter to 0.1, you see the same trend that there is very little difference in water quality. And that's really important to know because really currently the wastewater treatment plants are sort of committed to going to the 2030 target is 0.5 milligrams per liter. And there is, Elena GP is saying is whether they should go to 0.1. These results show that since the blue line and the green line are not much different, right? It doesn't make sense for the plants to invest in going from 0.5 to 0.1 milligrams per TP. So what could be done then to help address the other issues? Well, this is when really the dams comes into play. So the picture on the right shows sort of the longitudinal plot of the Fox. And the dams on the Fox are actually located on the reach that has higher slopes. But because of all these dams in series, the system actually behaves as a series of lakes. So in between these dams, you have slow moving reaches that are ideal for benthic algae growth. So we actually modeled what will happen if dams were removed. Initially, for one scenario, we looked at removing only the 2 dams, which are the priority for removal. And then for the second scenario, we looked at removing all the 9 dams from Carpentersville all the way to Montgomery. And we made obviously some assumptions on the dam removal, that dam removal would result in increased velocities. Because the system will become more free-flowing, the benthic algae coverage would be reduced, and there will be also reduced sediment oxygen demand that usually happens at the dam locations. So here's the results of the dam removal. So the dam removal doesn't really change what happens to the in-stream TP, and you don't really see a change in the systonic chlorophyll. What you really see is the impact on the benthic algae. So, but if you remove all the dams along the Fox, you really see a change in the benthic algae because the river is moving faster. It's not conducive to growth of benthic algae, and you see that impact where the green line really shows that, okay, the benthic algae is substantially reduced. And because of that, because the benthic algae is reduced, you see a substantial improvement in DO that happens as a result of the benthic algae, growth reducing. So just to summarize, for our watershed scenarios, as I mentioned earlier, the upstream TP load reductions only improve DO and algae in only the upstream reaches. If you only look at tributary load reductions, it does not significantly impact the main stem Fox River water quality. Treatment plants would have an impact in improving the DO, but going from 0.5 to 0.1 doesn't really give you the bang for the buck in terms of improving the water quality. Dam removal, if done correctly, this is where, when you do dam removal, making sure that you have rapids, you have shading along the river would significantly improve the DO in the upstream and the downstream reaches. So this is just a summary of the different watershed scenarios. So what happens next? So the next step is, now we know that, okay, if these scenarios are done alone, what's the impact? The model will be used to simulate the combined watershed scenarios. So we're going to be looking at a combination of those scenarios. Then once that's done, we're going to be working with a work group to agree on the necessary recommended steps for implementation. And that's really going to go in the Fox River implementation plan, and that will be submitted to IEPA by the end of next year. And then this slide is showing the different combined watershed scenarios. So here we're sort of combining all those 4 scenarios and looking at, okay, if you combine these different scenarios and sort of take it in a timeline fashion of when these scenarios will be implemented, what is going to be the incremental impact of the combined action of those scenarios. So that is currently in progress. And then finally, I'd like to end with a discussion. This approach is very unique in terms of addressing water quality. As Cindy mentions, the Fox River Study Group started on this path about 20 years ago, and it is an alternative to TMDL. In fact, this approach has now been adopted by Illinois EPA really on a statewide basis, where they are encouraging the different stakeholders in the watershed group to form these watershed groups to come together and figure out what needs to be done to address the water quality. And the study group has sort of invested a lot of effort in monitoring and modeling that would help inform the Fox River implementation plan. And I think you find very few instances where you have the POTW or the wastewater treatment plants, the environmental groups, the general public really working together to, they do work together, but not so much in a cohesive fashion as this group, to make sure there are improvements in the Fox River. And that's all I have. I think we can take some questions now. Thank you.
Yeah, we only have one question that came in, and does the model account for release of stored phosphorus from sediment?
Great question. There is a sediment flux in the model. So we use that as a calibration parameter, but I think we didn't have to put it to a very high value where it sort of played a very important role in the calibration. We initially started with some values and then basically calibrated it to the Instream data.
Okay, we didn't have any other questions come in, but you've still got a few minutes. I'm sure that you can expand on this a little bit more.
Yes, yes. So the way the model works is it has a sediment nutrient flux. So you can, for every reach, you can define a sediment nutrient flux. So you can say, okay, what is the flux coming from every reach? And typically you specify sediment nutrient flux in the impounded reaches, which are behind the dam, because that's where your sediments are gonna be. So that is what we provided as an input to the model. And when we ran the dam removal scenarios, we reduced that flux because ultimately that some of that sediment would be removed, and that would reduce the nutrient flux that's coming from the sediments behind the dam.
I think I wanted to say a couple of things that, you know, when we first used this model back in 2015, when we developed our Fox River implementation plan, the study group wasn't that confident in the model, so we didn't make any recommendations for dam removal at that time. But the work that Geosyntec has done, as Rishab showed us, you know, has really increased our confidence in the model and using it to make recommendations. So I think like Rishab said, we're going to be looking at a combination of scenarios, but I think coming out of this, we've been able to show with our model that we can see that we anticipate real improvements in dissolved oxygen with dam removal. And that in conjunction with this study that John Rogner was talking about, the Army Corps study looking at the benefits of dam removal on habitat and improving conductiviity for the movement of fish and mussels, really together, I think those really tell a great story about why we want to keep moving forward on removing dams in this part of the Fox River.
Okay, another question did come in. I know that the implementation plan is to be updated by the end of 2022, but do you have a concrete timeline for dates in which each of the 4 phases is to be accomplished?
I think that's a question back to me about my slide talking about the phases for the work of the Fox River Study Group, and we're really in the final phases of that work where it's kind of an iterative approach where we have developed these tools. We're doing water quality monitoring. We've developed and refined these tools. And so we're really at the point now where after we run these combined scenarios, then the study group will be working on you know, coming to consensus of what is the FRIP going to say in its next update in terms of what are the next steps that we want to take for improving the state of the Fox River over the coming years. So, so I would say we've completed steps 1, 2, and 3, and we're in the process of reiterating what's going to be the next projects that we're going to implement.
Okay, last question here. Can you elaborate about the importance of revegetation of riparian zones post-dam removal, particularly shading impacts on algae growth and water temperature?
No, that's a great question. And that's something that I talked about a little bit, but really, like I said, the benthic algae, like they can survive at very low nutrient concentrations, right? So really the controlling factor is what are if you remove the factors that are suitable for the growth, and really you can control the light. So once you have sort of removed the dams and reduced the width of the river, and you have riparian shading, that makes less light available for benthic algae to grow. And as we saw in the modeling results, that benthic algae have a huge impact. So by reducing the light, by having riparian vegetation along the former dam impoundments, that would drastically cut down on the light that's available to benthic algae. And that would definitely, like the modeling results are showing, and that's an assumption we made on the coverage, that when we reduce the, remove the dams, the benthic algae coverage would be reduced. So that's certainly, we are going to be in the implementation plan. That's one of the recommendations. I think that is something that the group is looking at, is how would this riparian vegetation be implemented for along the Fox River.
Okay, thanks Rishab and Cindy. We'll move on to the next presentation. Jamie Patton will be from Wisconsin DNR, will be speaking on promoting soil health on farm cost, risk, and rewards. Jamie.
Thank you, Ben. Hopefully, do you see the proper, do you see my presenter view, or do I need to switch over? Okay, perfect. So I'm Jamie Patton. I'm with UW Nutrient and Pest Management Program, and I know this group has heard about soil health before. So today we're going to take a little bit different look and look at why some farms may be a little hesitant to adopt some of these practices, in particular focusing on the economics impact of soil health on farms. So for those of you who are a little less familiar with soil health, let me get my slides advancing. What do I mean by promoting soil health? So oftentimes when we look at the science, they're focused on individual soil properties. So today I don't want to think about soil properties. I don't want to talk about soil organic matter or soil pH. I want us to think about soil function, because that's what's really impacting our ecosystem services. Is my soil interacting with the environment in such a way that's supporting biological communities, that is impacting water dynamics? Is water moving into my soil? Is it being stored for plant growth? Is it being filtered before it hits groundwater or surface water? Resources, are we storing carbon, so on or so forth? So thinking more on a functional type basis of soil health, because our question is our soil doing what we want it to do, and is it doing it well? And those are the questions when I talk about soil health that I try and answer. So what are some foundational soil health practices? So if you've done any research into soil health, you've heard about the 4 foundational practices, and they're based upon primarily year-round plant cover. When we think about reducing erosion, when we think about supporting those microbial communities, when we think about nutrient cycling and all of those properties that we want when we think about a properly functioning soil, much of them are based upon a year-round plant cover, having living roots in that soil, feeding that soil microbiology, adding organic matter into the system. So that is one of the foundational soil health practices. While it seems quite straightforward, oftentimes in our agricultural systems, that is a little bit harder to achieve. So you all are interested in the area down there in southeast Wisconsin, northeast Illinois. I'm sitting up in Green Bay. And so depending upon our climate, depending upon our soils, depending upon our crop rotations, sometimes this can be a little more difficult than it sounds. When we look at also those foundational practices, it's a reduction and or elimination of tillage. So making sure that we're keeping that soil intact, we're not destroying those soil aggregates, we're keeping that crop residue or that plant residue at the soil surface, and not exposing that soil to excess oxygen, like when we till, to stimulate those microbial communities to reduce carbon contents. And again, cropping system diversity and the addition of organics. Maybe in some systems that's compost, in others that's manure. For some of us that is a perennial type system where we're looking at grazing. So these are the 4 soil health principles that you pretty much have seen anywhere and everywhere, looking at that continuous living roots, minimizing disturbance, maximizing cover, maximizing diversity. But I also spent a lot of time, we'll use the word preaching, talking about the other factors, and that includes nutrient management planning, making sure that we're applying the nutrients that are going to be profitable within our system, but also maximize environmental quality, looking at integrated pest management, so only using those practices that are required to minimize pest damage at an economic level, and things that aren't talked about, like proper sizing of machinery, inflation of tires, following tracks. All of those have an impact on soil health. So when we talk about soil health, oftentimes we oversimplify oversimplify it and overgeneralize it, but it's actually a very complex system with a lot of interdisciplinary and interplay between different practices and strategies to produce crops. So when I talk to farmers about this, and when we all talk to farmers about this and talk about the community, we see opportunities everywhere. So this is a very optimistic approach. And then there's the other side of the coin where they see risks everywhere. Because oftentimes to adopt a soil health management system, we're going to need to adopt a different management style that's going to change how we manage our inputs. We're going to need different machinery. We're looking at potentially different crop rotations. If we have livestock in this scenario, we're looking at different feeding regimes, different feeds, so on and so forth. So it's a very complicated process to move from what we would call our traditional agricultural production systems into these soil health management systems that incorporate these four foundational practices of soil health. So when we look at the potential on-farm benefits, and again, we're going to look at the economics in a very general term, and we'll talk about that why in a second when we try and dig down deeper into those actual numbers. But when we think about those potential on-farm benefits, there's some short-term benefits. So switching from a tillage system to a no-tillage system, I'm going to reduce my field operations, I'm going to reduce the labor and time required. So there's going to be a benefit there. There's also potentially, if I'm reducing tillage or eliminating tillage, I can get rid of some of my machinery. So that's a potential for reduced input costs. There's also longer potential in longer term implementation changes in inputs, such as how much water if I'm irrigating. So if I improve my soil health to a point where I'm getting better infiltration and better storage, I may need less irrigation. I may need less nutrients. I may need less pesticides. But the key here is to focus on is I really dislike generalities. This is all of these short-term benefits and long-term benefits are going to be very much farm specific, soil specific, region specific, climate specific. And so the scenarios that we look today are generalizations of the impacts of these effects of soil health management systems. I do want to show you, and there's a lot of published information out there on these generalized impacts, and I pulled out table 4. So if you're really interested, you probably can't see the citation at the bottom. This is coming from SARE, the Sustainable Ag Research and Education Group. It's cover crop economics, and they published this really nice document looking at summarizing the impacts of implementing cover crops into crop rotation systems. And so I picked out table 4, which is focusing on crop rotations that include corn, so the corn portion of that rotation. And the thing I want to point out here is that this is a complicated system, and it actually grows over time. One, as those impacts of the soil health management systems compound upon themselves and the benefits start to acquire, but also the benefits of farmer knowledge, farmer experience over time and how that impacts the bottom line. So you'll notice that I've highlighted this orange bar here in the center of this basically partial budget looking at the impacts of cover crops on economics of soil health. And you'll notice under year 1, so this is 1 year of a cover cropping system, you'll notice that net return under a normal weather situation is negative. It's negative $31 per acre. So when we're talking with producers, I'm asking you to take a $31 per acre loss in the first year is pretty traumatic. That is not economically viable in many systems. Year 3, you'll notice that now we're at about a break-even point in their evaluation, and by year 5, they're seeing a potential benefit to positive benefit to net return. You'll notice that if you really dive down into this has to do with reduced fertilizer needs. That may or may not happen in many soils. So this is where it's really dependent upon that soil and its ability to provide nutrients. For those of you you have finer textured soils, that may be a realization that you're able to take advantage on. In my sandy soils up here, that may not be a realization. But in general, when we look at the benefits of soil health, and this in particular for cover crops, the take-home message here that I want us to think about is that oftentimes it takes several years to become profitable, and this is under normal weather years. It may be 3 years, it may be 5 years, or maybe more depending upon the system. Where these systems really shine, and I encourage you to dive into this table after we get done talking, is where these situations really shine is when we put pressure upon these agricultural systems. And oftentimes, I want to bring you, if you can see my cursor down here to point number 5, it says income for extra yield in a drought year. So by improving soil health, and you'll see this in the economic analyses, what we're doing is we're building the resiliency of these systems to withstand extreme weather events. So whether those be drought or flood events. And so when we look at point number 5 here, you'll notice even under year 1, year 3, and year 5, we're showing a benefit of changing our system from a conventional system to a soil health management system in that extreme weather year. Because again, we're improving that resiliency of that biology, that organic matter, the ability of that soil to function under extreme conditions. So there's a lot of potential benefits depending upon a given situation to adapting a soil health management system. There are also significant risks involved as well. So we talked about potentially reducing inputs needed for machinery, field operations, labor, and time. The converse is also true. When we start to incorporate cover crops into a system, this is more field passes. This is potentially, depending upon when these cover crops going in, specialized equipment to do that. Many of these farms are really pressed for labor, so we're now stretching labor thin, or we simply don't have the labor required to get many of these practices done. There's also some risks on field timeliness. So particularly in the northern reaches of the state of Wisconsin, I have a very short growing season, and therefore any day I lose in timeliness of planting, I'm going to lose potential yield. And we'll look at a diagram here. There's also risks associated with weed and disease insect pests, increasing those, as well as yield drag. So I pulled out a seed company put this out. So these 9 intended consequences of cover crops. We know from the last slide, there are potential economic benefits associated with that, but depending upon the situation and depending upon management, weather, so on and so forth, soil conditions, we can have these unintended consequences such as allelopathy, which is a natural chemical suppression of seed germination of the next crop. So what I'm saying is you plant a cover crop and the natural chemicals produced by that cover crop may kill the seedlings of your cash crop the next year. We could look at plug tile drainage. You can see expected overwintering becoming a weed pest. So there's some management issues also from adopting some of these practices. And last but not least, looking at this diagram, this is from Joe Lauer, our UW corn specialist, and it's showing that potential yield decline every day after planting after May 1. So if I have a cover crop in a soil health management system and we receive excess rainfall and I can't get into the field to terminate that cover crop and I have to delay planting past May 1, you'll notice after 7 days, 14 days, that yield decline is dramatic. And that is a potential risk, particularly not only economic when we look at corn grain systems, but in our livestock system, that's a potential risk for feed supply. And I can tell you over the last few winters and the last few growing seasons, our feed supplies oftentimes are in very low status, and any decrease in yield is going to impact not only my cropping system, but my livestock system. So while there's lots and lots of benefits to adopting these systems, there are potentially a lot of challenges and risks that need to be managed in order to get that adoption to be successful. So let's dive into the economics a little bit. So soil health management systems are fairly new, and it's very, very difficult to actually address the true impact on a bottom line because it is one very much region specific as well as farm specific. So there's some new studies that have come out very recently. And when I say very recently, the Soil Health Institute will be doing a series of webinars in the next month talking about their study that they just completed. So we're looking in the last few months, the studies that I've shown you have come out. So the economics of soil health systems on 100 farms by the Soil Health Institute and partners. What they did is they took 100 farms. All of them were in the corn soybean production region. Wisconsin was not included in this study. And they looked at how these soil health management systems, the reduced tillage, the increased cover crops, so on or so forth, impacted the bottom line of the farming operations. And you'll notice again, they assessed 100 different farms. They reported that 97% of those farms reported increased crop resiliency to extreme weather. And that's what I tried to talk about a little bit when we talked about the benefits. Where these systems really shine are hot, dry, wet, cold types of situations where we're needing that microbial community, that soil function to really shine in areas of extreme challenge. When we also looked at net income, they found that 85% of the net income for 85% of farms, excuse me, found an increase in net income. And if you slide down to the bottom right-hand corner, that increased net income was on average about $52 an acre for corn and about $45 an acre for soybeans. Unfortunately, they haven't published their full survey just yet. So what I would really want to know and what I really want to question here is, were these new soil health management systems, were these recently adopted practices, or how far were these farms in their soil health journey? As we know, these economic situations look very different from our previous slides. They look very different for year 1, year 3 of a soil health management system, year 5, year 7, year 10. So we know these benefits accumulate over time, and so understanding the details of the study are going to be important. Another study done by, as you can see, the Soil Health Net Partnership, as well as their environmental partners, looked at, and this is where looking at 7 farms. Again, this is very difficult to do, so they had a concentration on 7 farms. One of these farms was in Wisconsin, looking at the impact of introducing cover crops as well as conservation tillage into a corn-soybean rotation. And what I'm showing you here is the impact on costs, net return, and revenue. Corn is on the top, soybeans are on the bottom. And you'll notice I circled the dark green parts of the chart. That's what we want to focus on. That is the change in net return. So you'll notice if the adoption of cover crops, the recent adopters of those, the experienced adopters of those cover crops, conservation tillage with no cover crops, and conventional tillage with no cover crops. So we'll look at that far right-hand bar, and we'll look at that as our conventional system. You'll notice in that corn system, the net return was about $324 an acre. You'll notice for cover crops and recent adopters, they actually saw if the cover crops overall, and particularly those recent adopters of cover crops, saw a much lower net return to that practice and net lower return to that corn crop. So they're losing on average around $60 an acre for those early adoption of cover crops. So again, farmers that are trying to move into this type of system, this can be quite the deterrent. You'll notice over time, however, after you get into those experienced adopters, now we're actually seeing an increased profit over that conventional system. And the same holds true if you look at the chart down below for soybeans. The recent adopters see a tremendous hit in profitability, but over time that profitability starts to increase and can outpace that of the conventional practice. So it really is farmer specific, field specific, as well as experience specific. Looking at one more study as we move through, the influence of environmental practices on farm profitability. This is coming out of the University of Minnesota. So again, some of this data will come from Wisconsin, and what they did is they looked at the impact on EC, or these environmental, or what I'm calling a soil health management system, versus that conventional system, what they're calling average. And you'll notice on the bottom, they're comparing yields. And I will argue every day that I don't want to talk about yields, and that's why I put a big red X through it. It's not about yields, it's about profitability. And so am I doing something that's environmentally stable, but also can bring profit into my farming community? Because that profitability oftentimes is not sometimes related with yield. Chasing that high yield oftentimes is not profitable. So again, I put an orange bar about what I wanted us to focus on, and this is the net return per acre. And the point I'm trying to make here with this table is when we look at corn soybean production, you'll notice that environmental practice, or that soil health management system in their study, was profitable for corn. It was not profitable as compared to the conventional system as compared to soybeans. When we look at livestock-based systems now, there's also some disparity. Corn silage, you'll notice those soil health management systems have about half of the net return per acre versus the conventional system, where the alfalfa hay actually saw a boost from that soil health management system. The whole point here of showing you all this data is that this is very, very variable. So I can't come in here and tell you and overgeneralize this information and tell you that adopting a soil health management system is going to be potentially beneficial economically for these farmers. In the short term, or the long term. It really is site specific, it's crop specific, it's region specific. So I just wanted us to take a look at some of these economics that are out there. And you'll notice, again, we're not looking at a large data set. The first study looked at 100 farms, the second data set looked at 7 farms, and right now this data set, you'll notice, depending upon the system, the number of farms included in these analyses is at most 37. The low is 16. So we don't have, because soil health and these soil health management systems are so new, we don't have a good grasp of their long-term impact on farm economics. We do, however, know that they do have potential societal benefits. And so we saw this diagram earlier on when I talked about how I wanted to focus on soil function. When we look at soil function, we know that if we improve soil health, we improve the way in which that soil interacts within the environment, that we're going to see ecosystem services. We do see societal benefits such as flood control, improved water quality, improved insect potential diversity within the ecosystem. So there's a list here, not an exhaustive list here in this diagram. But again, these are all going to be very much regional specific. But we know overall, adopting soil health management systems in watersheds typically has an improvement of soil ecosystem as well as overall ecosystem benefits. So how do we support this conversion from conventional agriculture into these soil health management systems? And I'm just going to show you some of the local initiatives that I'm familiar with, as well as some regional initiatives, as well as some national initiatives. So first of all, when we think about the adoption of these systems, this is a change in a mindset. It's actually a change in a management system. It takes new knowledge, new techniques, new strategies, new skills to properly adopt these soil health management systems. And so we have 2 initiatives in the state of Wisconsin that are focusing on farmer education and farmer demonstrations to highlight these practices and what they can do for not only on-farm ecosystem services, but off-farm ecosystem services as well. One of those is the demonstration farm network, and unfortunately I couldn't find a good diagram of that, but I basically circled where they're at. So many of these are in the upper northeast part of Wisconsin. The demonstration farm network is supported by the USDA, NRCS, as well as the Great Lakes Restoration Initiative. And these are a series of farms that are adopting soil health management system practices and highlighting those and providing education as fact sheets, field days, videos, so on or so forth on these practices, trying to get this information and skill set out to a wide variety of farmers within these regions. DATCAP, the Department of Ag, Trade and Consumer Protection, also has a similar-ish type program where producer-led watersheds are popping up across the state. They get funding from DATCAP, and they're able to provide education to local farmers on some of these new practices, as well as financially support some of these practices to their members. In your area, you have the Watershed Protection Committee of Racine County. They're very active. I've been down and stood in a soil pit and talked about how these practices can improve soil function over time. So again, these organizations are farmer-led, they're peer groups, they're pushing information out into these systems to try and to promote adoption of these management systems across the state. There's also broad scale support for soil health movement across the state, whether it be NGOs, our tribal partners, water treatment plants, municipalities. You can see I listed a bunch of things here. Our high schools are getting involved, so I've done some presentations on how we can adopt some soil health information into our high school curriculums and start to change the mindset earlier on within our communities. But this is not an exhaustive list, but I just put some of the logos out there of partnerships that I've worked with to promote soil health and soil health management practices within our farming communities. So some of these are providing just technical support, and a lot of technical support is required to facilitate this adoption. Because it is a new change in our farming community, we need those quote unquote experts out there helping to troubleshoot some of the issues that are coming up, helping to identify what equipment is appropriate, what hybrids are appropriate, so on and so forth. So this technical service providers are extremely important. The boots on the ground are extremely important in helping to adopt these management systems on a broad scale. We're also gaining financial support from many of these organizations, so our federal agencies as well as some of our NGOs. Pheasants Forever, for example, I've worked with them on adapting some pollinator habitats in some of our farm fields, as well as our state agencies, and getting that funding into farmers' hands so that hopefully we can offset some of those initial potential financial costs and risks to move the system along where we're starting to see that benefit financially within these farms. So lots of movement out there within our communities to support soil health. And there's also now a broad scale effort nationally to support soil health. And many of you have probably seen the initiatives coming out of General Mills. They're supporting soil health, particularly right now they're focused in the Great Plains looking at wheat production. We have partners for, you'll see Annie's Honey Nut Cheerios, so on and so forth. In that diagram, partners for pollinator habitat. McDonald's and Walmart are in on some of the initiatives as well, looking at sourcing sustainably produced foods, many of these on soil health management system type farms. So there's a lot of movement out there to provide support, and it's going to take that financial support, but again, also that technical support out there within our communities to move the soil health movement along. We know the benefits are potentially great for not only our ecosystem services for all citizens within the area, but there's also, as we move past some of the initial challenges within the farming system, there can be potential benefits, farm-specific benefits to this adoption, but oftentimes it takes time. And that's right now, the early adopters for these technologies understand this and they're grasping it and they're running, and there's some amazing innovation happening on our farms across Wisconsin and Illinois. And so now we're moving that to some of our later adopters, moving this technology and what it really is, this technology and this mindset towards agriculture production out throughout the farming community. So with that, I was able to get done in a half an hour. So if we have some questions, Ben, I would be happy to answer those.
Yeah, we do. Can you provide a link to the upcoming Soil Health Institute webinars?
I sure can. So I will get that here in a second. So if you're looking specifically at the economics ones, let me pull that back out of my slideshow. Whoops, as I say, the joys of running dual screens. I'll pull that back out and I will put that in the chat box so that you can all find that information. So the whole Soil Health Partnership, if you've never been to their website, it is a group of university as well as extension personnel that are working to help identify what soil health really is. I think we're still trying to define that over time, but also helping us to find ways in which to promote adoption across the landscape. So that link is coming to you right now. Oh, and that probably doesn't go anywhere, does it? as we're streaming. So I gave it to Ben. I don't know how to get it to you all out in the virtual world, but I got the link to Ben. Okay, so
I will try to copy that.
You betcha.
Another question, are there other examples of supporting farmers, equipment, labor, or timelessness in planting to help new adopters implement soil health BMPSs?
Yep, you betcha. So I'll be honest, I'm most familiar with up here in Northeast Wisconsin. So what's happening is many of our local county land and water conservation districts have gotten grants, and so there's this opportunity to share some of this new innovative equipment. So things such as roller crimpers, such as interseeders to get cover crops planted in season to already a standing crop. You're seeing some of this adoption of low disturbance manure applicators if you're interested in livestock technologies. So there's a lot of initiative by NGOs in this area as well as our county land conservation districts to facilitate the movement of this new equipment out into the landscape. Let people try it, see if the practice works for them before they make these really large investments in equipment. So for those of us who don't buy farm equipment on a regular basis, these are, this is a $10,000, $100,000 purchase depending upon what piece of equipment we're looking at. We're looking at significant investments. So if we can try that out and figure out what we need and we want before we purchase it, it's an ideal situation, and those rental programs or those loan programs are very, very popular up here.
Okay, last question. Are you familiar with any other organizations in other farm states that are similar to the Demonstration Farm Network here in Wisconsin?
There are. So there's the Practical Farmers of Iowa. So I'm more familiar with the ones across the Midwest. So the Practical Farmers of Iowa is a very similar type organization. So a coalition of farmers that are doing on-farm research and education to peer networks. You're also seeing across the country the pop-up of these soil health coalitions within particular states. And what they're doing is, again, working with farmers, bringing them together along with their technical service providers, agencies, as well as university folks to brainstorm and to also bring together these minds. So what's really fun about working in this realm is there is a tremendous wealth of knowledge out there on farm. It's providing the connections of who's doing what is going well, what isn't going well, and sharing that information across the statewide network. And so there's a lot of initiatives right now to build those coalitions, build those networks, build those communities so that information can be shared freely amongst interested individuals. So it's really taking hold. So this is where soil health has only been around for maybe the last 20-ish years, but it's really gaining momentum in the last 5, and there's new and exciting things on the horizon.
Okay, thanks, Jamie. Well, we're out of time. Thank you, Jamie and Rishab and Cindy for your presentations. Now we have a lunch break and we will resume the Fox River Summit at 1:15. So follow your links for this afternoon's presentations. Thank you.